Good morning again. I'm here with David Colliaux from the sustainability team of our lab. And we are going to face such an interesting topic with him. I'll ask him something about what we have just said outside. So, hello, David. Thank you for being here.
Hello, Milena.
Hello.
Thank you.
And can you just say something about yourself and your work in the lab?
Yes, so I'm a researcher at Paris CSL from 5 years now, and I have been involved in the robotics for microfarms project from the start, so 4 years ago. And so we develop robots, and I'm mostly involved in the computer vision and machine learning parts. And also on the side, I'm interested in mathematical models in biology.
Thank you. And we just saw the presentation outside about the rover and the scanner. Are you working in the same projects?
Sure. And so, as I said, I'm mostly into the computer vision and machine learning parts. Um, so, if you want, I can tell you more about
Yeah, of
how
course.
it works
Yeah,
with a
yeah.
few images.
Okay, yeah. So maybe you can just show how it works and more about the project.
Yes. So, what you see here is the ROMI Rover. You already saw it on the stand if you're on the Maker Fair or in the presentation by Douglas. And this was 2 weeks ago, actually, in the center of France. We participated in a competition, agricultural robot competition, and the task for the competition was weeding, removing the weeds. And you can see on the side of the screen the weeding tool of a rover. So with this tool, we scratch the surface of the soil to remove the weeds. So you might wonder, how do we remove the weeds only and not the plants? So for this, first, we annotate data. So uh, you can see here the image from the top camera of the rover on the left side. And we want to tell the robots where are the plants, where are the weeds. So manually, we draw the contours of the plants, the contours of the weeds, and we produce images like you see on the right, with plants in gray, weeds in white, and soil in black. And so we do this for a lot of images, and it takes a lot of time. When we have a set of images and their corresponding mask, we can give this to a computer, to a deep learning algorithm, so that it learns to recognize the plants and the weeds. And so you see here a schema of a network we use. It has an encoding pathway along which the information is compressed, and a decoding pathway where the information is expanded again to produce the mask. And deep learning may be a bit intimidating on the mathematical aspect of it, but it's actually nowadays very easy to use. So we use a unit architecture implemented in Python with a library TensorFlow 2. And I encourage you, if you have some images you want to test it on, to go to see on the internet. You can check, for example, the segmentation models library, which is very well documented in terms of tutorial and installation procedure. So really, I encourage everybody to try it.
Yeah.
And so after we've got the mask with the plants located, we spread a set of points on the soil, and we compute a path. We compute a path where the tool will go to remove the weeds. And so you can see on the image what the path looks like.
Okay, great. It seems to me you talked a lot about neural network. So do you collect a lot of data?
Yes, so we collect a lot of data, and we work with neural networks. So we have to annotate the data. But in some case, for example, when we do 3D, as explained by Nabil, um, we can't realistically annotate thousands of point clouds by hand. So what we do instead, we use a framework for creating virtual plants, models of plants, 3D models of plants. So we use LPI, which was developed by a partner of ROMI project in RIA in France. And so we can generate the plant in 3D. And because we generated the plant, we know where are the fruits, we know where are the leaves, we know where is the stem. So we can have ground truth annotation for free. And so we can generate thousands of plants like this and give this to the neural networks to learn.
Okay. So, and why this part you have just explained is so important?
Um, so you mean
The imaging, the reconstruction.
yes, okay. So maybe I will explain a bit more
Yeah, you can go further.
what the reconstruction is about. So with the scanner, we take many images of a plant around the plant. And from these images, we produce mask again with segmentation algorithm to distinguish the plant from the background. And we have thus a set of masks, and knowing the silhouette of the plant and the position of the camera, we can generate a point cloud, which is a large collection of points in 3D, representing the structure of the plant. So how do we do that? This is called space carving. And the basic principle is if you have the position of the cameras where the picture were taken and the silhouette of the plant, you can carve the space to construct the 3D shape, which is compatible with all of those silhouettes. That
Okay.
way we can reconstruct the plant in 3D. And so why is it important? Because we want to study the 3D structure of the plant. Like, for example, to determine the size of the fruits or the angles between the fruits. So we have to segment in 3D the plant to isolate each part of the plant so that we can measure it and give this data to biologists. So we use, again, a segmentation algorithm either on the images and we project back the labels in 3D, or we use some recent techniques in neural networks which are specific to point clouds to do the 3D segmentation using the 3D points as input.
Okay.
And so maybe I can explain a bit more how
Yes.
we use it. So then we do acquisitions over days. Like you see 7 days of acquisition here for 3 plants. And we want to make the correspondence between plants, to know which points map to which points in the plant. And so for this, we developed with a student last summer. We developed an algorithm which can make automatically the matching between the point clouds. And so we can use this data to do phenotyping, the characterization of plants. So, for example, you see here the curves for the growth of each branch. And this is very interesting data for biologists to follow the statistics of growth of a plant. Another application of the correspondence matching is to interpolate the point clouds. So, for example, let's say you have the point clouds on Monday and the point cloud on Thursday, on Wednesday, and you want to know what was the point cloud on Tuesday like. If you know the two point clouds and their matching, you can interpolate the point cloud in between.
Okay.
And actually,
Great.
phenotyping, it's also useful for agronomy and for farmers. So we do this with 2D images of a plant. where you can estimate the size of a plant by its area. It's true when the plant is quite flat. And so for all the images we collect with the robot, we can draw growth curves for the plants and statistics for the growth of the plant. And so what we want to do also, I should say, in the project up to now, we mostly work with monoculture, but in agroecology, it's a very interesting topic to look at intercrop system, mixing several species together.
Okay.
And what we want to know is how to what is the good layout for such mixed system, how to plant them, and using the growth curve of the plants, we can imagine various systems. So you see here on the right a quite geometric pattern to plant lettuces and cabbages. And on the left, you can see a more random planting of the two plants. And knowing the growth of the plants, we can study those planting patterns and decide which is better. And it's also interesting from a modeling point of view because having different time scales, those species gives rise to very complex dynamics, which we can study using complex systems.
Okay, thank you. So actually, this project gives the opportunity to know a lot about plants and how and their behavior on a field. So it seems to me that we have a lot of data collected, and that you can use this data for a variety of things to study and improving.
Yes, yes. And actually, agronomists are used to deal with a lot of data,
Hmm.
but for intercrop system, like I described,
Hmm.
we don't have so many data. And what I imagine, for example, would be to have robots like we have in many farms, the data shared between farmers and researchers, and to have open science project to study intercrop system.
Yeah, because I mean, the the sharing of knowledge about these topics is very important actually for farmers, and to join also a sharing system of knowledge about the cultivations and the know-how.
Yes, yes. And in Paris, we have a great chance to be a really central area for agroecology. It's very interesting that agroecology got a big popularity from the 70s, let's say,
Hmm.
in America, in Australia. But they really relied on knowledge from the farmers in Paris, which is collected in old books. So yeah, I would really like to see how the knowledge from the 19th century in Paris percolated in the 20th century and 21st century. It would be
Okay.
interesting to look at that. Yeah.
Yeah, yeah. And have you been working on this project for a long time?
So I joined the team led by Peter 5 years ago,
Okay.
and so we started with a wooden robot, a bit shaky, and so we started the European project 4 years ago,
Okay.
and now it's a seventh version of the robot.
Wow.
So we went a long way
So
along this project.
he it grew up the project.
Yeah,
Yeah.
yeah.
Okay. And how it was to work on this project? I mean, from a personal point of view.
It's amazing for me. We get to build stuff like we have a workshop and we are already cutting woods and soldering electronics and also to lead research on machine learning and computer vision, to study biology with biologists. So it is really wide
Yeah.
skills we can develop in this project.
Okay. And before you told about the students, so maybe you achieved to have the attention the attention by students on these projects.
Yes, yes,
So,
I was very happy of the work we did with Howlin Pan last year. Actually, he wrote a paper which is accepted in a nice conference uh, um, this year. So, so yeah, he did a great job. And maybe you saw the small plant carrier robot on the stand.
outside, yeah.
And this is also work we did with a student of an engineering school just next to the lab. And also I should say the lab is in the fifth arrondissement of Paris.
Uh-huh.
We are surrounded by students,
Oh,
so
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 it's
it's really great
great. Yeah,
to have
because
interactions with them.
yeah, also for the education to sustainability, it's a great thing to be in touch with students. They
Yes, yes, and we also have projects with students in ecophysiology.
Oh, great.
Because in Paris Sorbonne University there is a fab lab dedicated to biology called the Green Lab, and we are happy to collaborate with them and to share projects with students about ecophysiology. Yep.
Okay, okay. So thank you, David, and thank you for actually explaining us a little bit more what we have just said, just so outside. And now we will pass to another interview to a
Thank you.
colleague of you. And I really thank you for being here.
My pleasure.
Thanks. Thanks.